Hello dear student, in today's class we will study big omega notation. Previously we have studied the big O notation. These two have some similarities and some differences as well. Big omega notation is also used to represent time complexity and space complexity as well. Big omega notation defines a lower bound on order of growth of time taken by an algorithm or code with input size. So, big omega defines lower bound on order of growth of time taken by an algorithm or code with input size. Let f of n define running time of any algorithm. F of n is said to be big omega of g of n if there exist positive constants c at n0 such that c of g of n is greater equal to 0 but lesser equal to f of n for all n greater or equal to n0. Here n is used to give lower bound on a function. If a function is big omega of n square, it is automatically big omega of n as well. So from this graphical representation, we can understand it very clearly. Here the x-axis represents the n, which is used to give the lower bound on a function, and the y-axis represents the time. And these two are the growth curves. Here f of n is representing by this line, this growth curve line, and c of g of n is representing this. And this point is n0. These two are intersecting here. And for all n greater or equal to n0, this condition is satisfied. The condition is c of g of n is lesser than f of n. We can easily see lesser than or equal to f of n for all n greater equal to n0, and it is also greater than 0 because there is no negativity in negative x-axis. So this was all about big omega notation. Next we will study big theta notation. Thank you.